What happens if you have a permutation but things repeat? Well, if that's the case, we have a slightly different formula. We still do our same part. That is, I'm going to take n factorial, but then I'm going to divide it by the things that repeat. So if I have something that repeats r1 times and another thing repeats r2 times, I just take r factorial times r2 factorial and so on if they repeat a bunch of times. So let's apply that to a problem here. On a game show, a contestant has to arrange five number tiles to build their guesses at the prize. Okay, can't talk. Sydney is given 5 tiles, so we know with the numbers 2, 2, 5, 5, and 8. If Sydney has to arrange the tiles randomly, what's the probability she's going to get the correct answer? So in other words, she's not going to look. She's just going to do the reach in, put them in any order randomly. So to find our sample space, we are going to look at, this case, she has 5 numbers, doesn't it? So it'll be 5 factorial. Well, notice the 2 repeats, doesn't it? How many times does it repeat? It repeats twice. So it'll be 2 factorial times, and the 5 repeats also, and that repeats twice also, over 5, over 2 factorial again, because it repeats twice. Now the 8 doesn't repeat, so we don't have to worry about it. I guess we could say 1 factorial if you wanted to. So in other words, this 5 factorial, let's just do this on the calculator. We're going to do 5 factorial, function factorial, and I'm going to divide that by 2 factorial times 2 factorial. And we get 30 different ways. So because of the repeating part, there's only 30 different ways that Sydney could put these in different orders. There's 30 different orders, but only one of them gives us 2,852. So the probability of her selecting 25,852, there's only one of those, isn't it? So it's 1 out of 30. As a decimal, let's take 1 divided by 30. So she has about a 3% chance of getting the correct answer just by randomness. And I'm guessing she probably would not do just random. She'd kind of looking at the game, she would notice the difference between if it's 20,000 or 80,000 or 50,000 or 5,000, and then go from there. She might have to do random for some of it, but not the whole thing. Now, a combination is usually what we see. That's where the order matters. So if you play bingo, it doesn't matter what order the numbers match your card as long as they match your card. Okay? That's the same thing goes if you watch the lottery. If you select the numbers, the order you select the numbers doesn't matter. It's just as long as they match up. Now we throw in the Powerball, that's a little bit different. That's where the last one has to match exactly what you picked. But when we do probability that require combinations, we're usually going to do our combinations for the favorable outcomes to the total outcomes, and we're going to write that as a combination and then do our probability from there.